Here's a question you'll almost definitely face in a data science interview. Your dataset violates normality assumptions. Do you transform it, use a different test, or proceed anyway? This question reveals whether you really understand your data, not just the tools. Let's simplify it. Parametric tests, like t-tests or ANOVA, assume your data follows a particular distribution, usually normal. They use the actual data values, the means, the variances, to make precise comparisons. When those assumptions hold true, they're strong and statistically powerful, but real-world data rarely behaves that nicely. Think of customer income, website visit times, or product reviews, data that's messy, skewed, or full of outliers. That's where non-parametric tests come in. These are distribution-free tests. They don't care about the data's shape. They rely on ranks or medians instead of raw means, making them much more reliable when your data breaks the rules. If you picture it, the smooth red bell curve on your left, that's perfect for parametric tests. The uneven red bars on your right, that's real data, handled best by non-parametric tests, like Mann-Whitney-U or Kruskal-Wallis. So, remember this simple intuition. Parametric tests assume structure, non-parametric tests adapt to reality. Now, here's where interviewers really pay attention. Can you connect this to how you'd handle data on the job? Most real data you'll analyze, like session durations, customer spends, or time to conversion, is right skewed, meaning a few users behave very differently from the rest. If you use a parametric test assuming everything's normal, your results might look statistically valid, but your business decision could be completely wrong. That's the trade-off every data scientist needs to manage. When assumptions hold, parametric tests are powerful. When data violates those assumptions, non-parametric tests are your safeguard, slightly less powerful, but far more trustworthy. Now, here's how you can confidently respond in an interview. Parametric tests assume a specific distribution, usually normal, and use parameters like means. They're precise but sensitive to assumption errors. Non-parametric tests make fewer assumptions, using ranks instead. I'd choose parametric tests for large, roughly normal datasets, but switch to Mann-Whitney or Kruskal-Wallis for skewed or ordinal data. That's the kind of answer that shows you're not just running tests. You understand when to trust your data and when to challenge it. That judgment, not the formulas, is what separates a good data scientist from a great one.